Don't tell the other guy here, all right? Don't tell him, because I'm giving up a least common multiple trick for you. You're going to love this. What's that? Other guy, I don't know where he is. How do I? He's off jumping and clapping somewhere. Who knows where he is? We know what he'd do here, right? Prime factorization. That trick's for suckers. Well, now I shouldn't lie to you. That's a pretty cool trick, but try it here. You'll be here all day trying to find these prime factorizations. I'm going to show you something really cool to take care of this. And to do that, we're going to start with a simpler problem. What? Oh, other guy does a simpler problem thing too? He takes all my good stuff. All right, this is mine. Got that? Here we go. Simpler problem. We're going to start off by finding the least common multiple of a couple simpler numbers. We're going to start just with, let's see, we'll start with 2 times 3 and 2 squared times 5. And we know how to find the least common multiple of these, right? We take the highest power of 2 in these prime factorizations, and we take the highest power of 3, the 3, and the highest power of 5, which is the 5. Yeah, the prime factorization thing's still pretty useful, but we're going to use it to develop an even sneakier way to find least common multiples. All right, so we have this down, right? Now what happens if we multiply each of these numbers by 2? Our first number becomes 2 squared times 3. And our second number becomes 2 cubed times 5. And now our highest power of 2 is 2 cubed. And we still have our 3, and we still have our 5. So we multiplied each number by 2, and that multiplied the least common multiple by 2. Maybe we got lucky. Let's try this again, all right? We're going to multiply each of these numbers by 2 again. So our first number becomes 2 cubed times 3. And our second number becomes 2 to the 4th times 5. And now our highest power of 2 is 2 to the 4th. And we still have a 3 and we still have a 5. Multiplied each of these numbers by 2, and that multiplied the least common multiple by 2. Maybe it's just something special about 2. Let's try multiplying by something else. I'm going to multiply by 3. Multiply each of these numbers by 3. The first number becomes 2 cubed times 3 squared. The second number becomes 2 to the 4th times 3 times 5. And now when I find the least common multiple of these, the highest power of 2 is still 2 to the 4th. The highest power of 3 is now 3 squared. And of course I still have my 5. So I multiplied each of these numbers by 3, and that multiplied the least common multiple by 3. So now look what I did all the way through this. From here to here, I multiplied each number by 2 2's and 1 3. And as a result, look what happened to the least common multiple. It got multiplied by 2 2's and 1 3. And in the same way, if I start with any two integers, a and b, and I multiply them both by some other integer, n, and then I find the least common multiple of these two new numbers, the least common multiple will be just n times the least common multiple of the numbers I started with. So anytime I'm taking the least common multiple of two numbers that have a common factor, like n is here, I can factor that common factor out. I can pull the n out so that the least common multiple of n times a and n times b is n times the least common multiple of a and b. Let's put this to work on that other problem, and you'll see how cool it is. So we got these two massive numbers here, right? They've obviously got a common factor. They're both even. They're both divisible by 2. So what I'm going to do here is I'm going to factor that 2 out. So first we're going to write these as 2 times something. So this is just the LCM of 2. Let's see, divide this by 2. 2 goes into 9. Let's see, that's 4. Carry the 1. 16. 4, 8. 4, 8. 4. And all I did was divide 2 into that massive number there. I'm going to do the same thing here. I'm going to pull out a 2. That's going to leave me 36, 36, 3. 36, 36, 3. And now I've got this common factor of 2. I can pull it out of the least common multiple. This is 2 times the least common multiple of 4, 8, 4, 8, 4. 3, 6, 3, 6, 3. All right, and now look at these two numbers. They certainly follow a similar pattern. I mean, this is just 4 times 1, 2, 1, 2, 1. This is 3 times 1, 2, 1, 2, 1. It's fun to say. Say it with me. 1, 2, 1, 2, 1. Yeah, that's fun. So check this out. Good. These have a pretty obvious common factor. 1, 2, 1, 2, 1. This is 4 times 1, 2, 1, 2, 1. And this is 3 times 1, 2, 1, 2, 1. And now we've got a common factor, 1, 2, 1, 2, 1. So I'm going to pull out the 1, 2, 1, 2, 1. I can pull out that common factor. And I'm left with 2 times 1, 2, 1, 2, 1 times the least common multiple of just 4 and 3. And of course, the least common multiple of 4 and 3, that's just 12. So I've got 2 times 1, 2, 1, 2, 1 times 12. Now I can just multiply this out. 2 times 1, 2, 1, 2, 1 is, of course, 2, 4, 2, 4, 2 times, I'm going to write this 12 as just 10 plus 2. That makes figuring this out much easier. We'll do this right over here. 2, 4, 2, 4, 2 times 10. We just stick the 0 on. And then times 2, that's 4, 8, 4, 8, 4. Just throwing a little distributive property your way. We just add those up. 4, 0, 9, 0, 9. And there's our answer, 290,904, and we're done. What's that? Other guy uses that too. All right, well, here we go. All we're doing here is using the secret factoring out trick with the least common multiple. Here's another secret. Check this out with greatest common divisor. It works there too. But you didn't hear that from me.